Hi, I'm Raymond Lin, and this is Strategic Math. In our 8th lecture, we're going to talk about special angles in geometry. So these are the angles that we're going to talk about today. 15 degrees, 22.5 degrees, 90 degrees, 30 degrees, and 67.5 degrees. So before we begin, there are two kinds of special angles that you need to know. One is the 30 and 60 degree, and the other is the 45 and 45 degrees. You also need to remember the ratio of their lengths. So let's now look at 15 degrees. So we're going to talk about how you get the length ratios of 15 degrees. The first thing that you can notice is that 15 degrees is a half of the 30 degrees. So we'll draw out a 30 degrees triangle, and then we'll let 30 degrees become an external angle, and let's draw an isosceles triangle, which has an angle of 15 degrees. So we'll now label the length that we've already know and we can derive from the triangle 30 and 60 degrees. And this is how we get the other length, which is the square root of 2 plus the square root of 6. We can use the same way to get the ratio for 22.5 degrees. So let's now look at our today's first question. So our first question involves the degrees that we've talked about and 90 degrees. Well, the diagram looks like this and it asks for x. So you've noticed that there's a 30 degrees and there's a 15 degrees. So if we have a 30 degrees, why don't we get a 30 and 60 and 90 degrees? This will get us a 45 degrees. Notice that if we connect the two lines, what we'll get is like this. We've got an equilateral triangle on the right and a 30 and 30 degrees on the left. This means that we've got a 45 and 45 degrees at here and here. This means that these two lengths will be the same, which means that x equals to 180 minus 30 divided by 2 minus 45 equals to 30. Well then, let's now look at 30 degrees. Well, you can see that there's a rectangle here and it has a length of 4 and a width of 1. So you've already seen a 90 degrees and you've seen a 1 degree and 4. You've seen a length of 1 and a length of 4. What you can think about is if we multiply the length of 1 by 2, then what we can get is a 2 and 4 ratio, and we can derive a 30 and 60 degrees. So we'll rotate and flip the triangle. We'll flip the triangle to form another isosceles triangle. We'll connect the lines. We can find that these 2 degrees will both be x. It is easy for us to find that these two triangles will be congruent. This means that these two lengths will be 1. 1 plus 1 equals to 2, and a 2 and 4 ratio will give us a 30 and 60 triangle. This means that the external angle 2x will be equal to 30 degrees, which means x equals to 15 degrees. Let's now look at 67.5 degrees. This question is actually a bit trickier. It says that its perimeter is 40 and is asked for its area. First, you can notice that this whole diagram is constituted of 4 lengths that I marked in blue and 4 lengths that I marked in yellow. This means that these two lengths are 10. You've already known the 22.2 degrees property, so you can use that ratio to solve this question. But the number doesn't look great, so why not we use another way. We'll rotate the rectangle like this. If we rotate the rectangle like this, we'll connect the two lines to form a diagonal line. We can easily see that these four areas will be the same, which means that the area of the whole diagram will just be 10 times 10 divided by 2, which is 50. And this is the answer for our question. And this is the end of our lecture. In our 9th lecture, we're going to talk about graph theory. See you then.